All right, we're going to solve a few logarithmic equations. So first thing to note is that when we're solving these, we want to have a single logarithm on one side all by itself. What we're going to use to solve these is going to be the definition of a logarithmic function, which is listed here in the middle. And what we're going to do is we're going to start with our logarithmic form. We're going to switch it over to exponential form and then solve the resulting equation. So to begin with, what I like to do is I like to identify our base for the log. So it's this subscript down here. So on the left one, it's going to be where the x is. We line that up, and it's going to be the base for the exponential part as well. So I'm going to start with my x, and then we want to determine what is this going to be raised to. So we can use the formula, of course, in the middle, or how I like to think about it is this kind of looks like x raised to the 9th power. So when we rewrite it, it's not going to be x raised to the 9th power. So it's going to end up being x raised to the 2nd power because that's on the other side. And this is going to be equal to 9. So now we have an equation, no more logarithms. This is a nice power equation. And to solve it, we'll go ahead and apply a square root to both sides. Usually we want to include a plus and minus because we applied a square root to both sides of the equation. On the left-hand side, we'll be left with x. On the right-hand side, we would normally say plus or minus. The square root of 9 works out to be 3. But because this started out as a logarithmic equation, what we want to remember is our base is where the x was. So our base, the b in this over here, the base has to be greater than 0, and it cannot equal 1. Well, we can't use both a positive and negative 3 in this case because negative 3 would be less than 0. So I'm going to get rid of the negative, and our only solution on this one is going to be x equals positive 3. Let's give it a shot on the one on the right-hand side next. So first, I'm going to identify my base is going to be 3, and then figure out what power should that be raised to. Again, this kind of looks like 3 raised to the 10 minus x power, so it's going to be 3 raised to whatever's on the other side. So in our case, 3 to the 3rd power, and then we have 10 minus x goes on the other side. To solve for x, what I'm going to do next is go ahead and say, well, 3 cubed means 3 times 3 times 3, which works out to be 27, equals 10 minus x. Nice linear equation at this point, so I'll subtract 10, move that away from our x. So 10 minus 10 makes 0 on that side. 27 minus 10 makes 17. And we still have a negative in front of our x on the right-hand side. To solve for x, we still need to get rid of that negative, so we can either multiply or divide both sides by a negative 1, because 2 negatives multiply and make a positive. So we end up with negative 17 on the left-hand side equals positive x. The last thing we want to probably double check is if we plug this back in, will we have a positive on the inside of our log? Remember, you can't take a log of a negative overall number on the inside here. So if we do plug it back in, it's going to be 10 minus a negative 17, which works out to be 10 plus 17, which is a positive 27. And that's okay for everything on the inside here to be a positive value. So I hope this helps out as you're working on these. Remember, isolate the log on one side all by itself, switch forms over to exponential form, and hopefully you can handle whatever equation you're given at that point. Good luck.